All right, we're going to look at extrema on an interval. So that's any maximums and minimums. We can kind of classify them as two different kinds. We've got relative or local extrema, which just means that a particular value is a maximum or a minimum relative to the ones around it. So if I do something like this point right here, relative to all the points around it, we'd say that's a maximum. And then an absolute is the highest or lowest on the entire domain of the function. So let's say I have something like this. I don't know if I've got a picture right down below, but something like this. So compared to ones around it, this is a maximum, maximum, minimum, minimum, maximum, right? But then this point right here would be the absolute lowest. So that would be an absolute minimum, right? All right, so let's look at an example. So we have a graph here. Determine the extrema on the interval from A to F. Okay, so we have this point here, I would say, is a relative minimum because it's a minimum in comparison to the points right around it. Here, I'd say we have a relative maximum because it's really high compared to the ones around it. And we have another relative minimum right here. I'm going to put a star by that just for a second. And then I've got this for a relative max. Also going to put a star here. And then, all right, I don't know any points to the size of these endpoints, so I'm not going to classify them as a maximum or a minimum. But now I'm going to look for the global or absolute max and min. So this point here is the highest on the domain. So instead of a relative maximum, we're going to call that an absolute maximum. And then same with this one here, I put a star on. Instead of relative, let's call that an absolute. We would include the endpoints if they were higher than either of those, or lower. Right. So we got another one here. State the relative extrema of the function. So I want just the local ones. So I kind of also will look at it to see if there's any absolute ones. And what I see here is that this goes off to infinity. So there's going to be no absolute maximum because infinity is not a number we can pinpoint, right? And then minimum, I do have one that is the lowest. So I won't include that in the relative because it is an absolute. I've seen arguments to where people count it as both, saying it is a relative minimum because in relation to the points around it, it's a relative minimum, but then it's also an absolute. And I'm cool with labeling it either way. So let's see, we have a relative max of, and here's what I'm gonna go into some like wording. So when we talk about what the actual maximum and minimum are, those are y values. So I have a relative maximum of 2 at x equals 2. You could give just the ordered pair, but if a question asks, what is the absolute max or what is the absolute min, we're looking for a y value. If it says where are they occurring, then we're looking for the x value. All right, relative minimum. I'm going to go with this one of 0 at x equals 4. I guess I should use the same word. All right. And then what is the absolute extrema? So there's no absolute max because of the going off to the infinities, But we do have an absolute minimum of -8 at x equals -3. Right? Let's get another one. We're going from 0 to 12. Find the relative extrema and the absolute. Okay. So I'm going to do the absolute first. So absolute max, absolute min. This is the highest. It's an absolute maximum of 7. And see, the function says, what are the absolutes? So I'm going to leave it as the y values. And the minimum, this is the lowest, so -2. Find the relative extrema. So relative max, relative min. I'm just going to give the ordered pair. It doesn't say what or where. I'm just going to give the ordered pair. So relative maximum. We could consider 7, 7 a relative max. I'll put a star there because it is the absolute. And then we want a minimum. I'll also put a star and do the 2, -2. But then we also have this point here. Is that 10, 2? Right? So we have something called the extreme value theorem. So if f is continuous on a closed interval a to b, then f has both a maximum value and a minimum value on that interval. So we have to check the endpoints as well, okay? All right, let's look at some examples for each. The graphs below explicitly state where the hypothesis of the EVT fails on the interval 0 to 3, and then determine if there's any extrema on the interval. So the hypothesis in an if-then statement is the if part. So if f is continuous on the closed interval, so from 0 to 3, not continuous at x equals 1. So it fails that first part, right? And then do we have some extrema on here? Yeah, we have an absolute minimum. And then we have an absolute maximum here. Okay. Let's look at B. We're also not continuous at, well, it looks about 1.5 at x equals 1.5. So it fails there. But I would say we still have some extrema, right? So got a maximum. And then wouldn't say we have a minimum at 1 because that's a whole, but we do have a value here, like really close to it, that I would say is a minimum. All right, from, what was our interval again? 0 to 3. So we're not continuous at x equals 0 because there's a hole there, right? So fails that hypothesis there. And then extrema, I wouldn't say we have any because we have that hole there. So sure, we could find a value really close to it, but then there's no absolute minimum because it's going off to -infinity. All right, and again, we are not continuous. We have holes on each of the endpoints. But I would say we have, here, not continuous at x equals 0 and x equals 3. Sorry, I had to pause my screen. I don't know what I last said. So to you, there's no cut, but to me, there was a break. So let's recap super fast. Not continuous at x equals 0 and x equals 3, but we do have an absolute maximum and then an absolute minimum on that interval. But the EVT doesn't guarantee that there is one because these are not continuous. All right. So we're going to talk about critical numbers here. So a critical number is a value, an x value, that's in the domain of the function. And this is where the first derivative is 0 or where the first derivative doesn't exist. All right, so if we have a critical value, x equals c, then we can find the actual point on the function, and that would be called a critical point. So what we're going to do is use some facts here. We're going to find the absolute extrema on the interval provided that the EVT is applicable, if not, justify why. So I have a polynomial here, right? And polynomials are continuous everywhere. So I'm guaranteed to have an absolute max and an absolute min on this interval. So what I need to find is where that possibly happens. So I have a cubic function here. Based off our pre-calc knowledge, we should know it looks something like this-ish, right? It looks kind of like the x cubed parent function in a sense. And what I'm looking for is any maximums or minimums, okay? So across the entire domain of the function, we would say that there isn't any because it goes off to the infinities, but we are only looking from -1 to 2. So we do have an absolute maximum and an absolute minimum. So I can look to see if I have either of those within that interval, which is where we have horizontal tangent lines. So where the first derivative is equal to 0 is what I want to solve for. But then I also want to check my endpoints. So let's find the first derivative. So we get 24x squared minus 6x minus 9. And I want to set that equal to 0. And I probably want to factor out something. I think I can factor out a 3, and that might help. So 8x squared minus 2x minus 3. There's a couple ways we can work this quadratic. Let's see if we can factor. I do slide and divide. So I slide this over and multiply. I'm going to divide both sides by 3. So I'm going to get 0. And then slide and divide it. So I have x squared minus 2x minus 24. And I think I can find two numbers that multiply to 24. Negative 24 and add to -2. Maybe 6 and 4, -6, +4. But because I slid that 8 over and multiplied, I just have to divide it back out, right? So really, I get, let's see, 6/8. If I reduce both of those by 2, that's 3/4. And then 4/8, that's 1/2. Then I can get both of those zeros, right? It's going to be 3/4 and -1/2. So if I think about my values here, so I need f, and then I need the actual function value. So I'm looking from -1 all the way to 2, and 3/4 and -1/2 are both in the interval. So -1/2, and then a +3/4. Now I want to find these function values because I want to find the highest and the lowest. So I'm going to go in a calculator off to the side. I'm going to plug in my function into the calculator. So that's 8x cubed minus 3x squared minus 9x plus 2. And then I can evaluate the function. If you're on like a normal graphing calculator, I think you can do, was it second trace for the calc menu, and then you can do value. You can plug in the values. So -1 is going to give me 0. -1/2 is going to give me 4.75. 3/4 is going to give me -3.0625. And then 2 is going to give me 36. All right, so we have an absolute maximum and an absolute minimum. I'm just going to give the ordered pairs. So absolute maximum, I want the highest value, which is going to be 36. So my ordered pair is 2, 36. And then the absolute minimum, the smallest one, is the -3. So 3/4 and -3.0625. Right? So get another one. So we've got x minus 2 sine of x from 0 to 2 pi. So let's find the derivative so I can find those critical points. All right, so set the derivative equal to 0. And then move some things over. I'll probably add the 2 cosine x over. Divide by 2. So where is cosine equal to 1/2? So if I look at a unit circle here, don't have it memorized like I should, but cosine is the x value. Where's it equal to 1/2? We have that at pi over 3 and 5 pi over 3. So now let's check some values. Oh, it's g of x. So I have 0, pi over 3, 5 pi over 3, and 2 pi. So let's find some. So if I plug in 0, I get 0. Here, I can go back into a calculator actually. Plug the function in, and then plug in values. So it's x minus 2 sine of x. And I want to plug in 0. It gives me 0. Then I want to plug in pi over 3. It gives me negative 0.6848. Let's do 5 pi over 3. Gives me 6.968. And then 2 pi. 2 pi gives me 6.28. It keeps going. Okay. So we need our max, absolute max, and absolute min. So the highest value is the 6.968. So 5 pi over 3 and 6.968. And then the smallest is the negative. So pi over 3 and negative 0.6848. Right? All right, let's do another one here. So let's find our derivative. It's going to have a chain rule with this first one. So it's going to be 2 sine of x times derivative of the inside, which will be cosine, and then plus sine of x. All right. Let's see. I want to set that equal to 0. And I think I can factor out a sine of x. I'm left with 2 cosine of x plus 1. Then I have 2 factors I can set equal to 0. So sine of x equals 0, and 2 cosine of x plus 1 equals 0. So sine of x between 0 and 3 pi over 2. It's going to happen at 0 and pi. And then here we would subtract 1, divide by 2. So I want cosine of x to be equal to negative 1/2. And that's going to happen at 2 pi over 3 and 4 pi over 3. Right, so we have some values to look at now. So I'm looking at 0 and then all the numbers in between. So 2 pi over 3 pi, 4 pi over 3, and then 3 pi over 2. All right, so let's go back in to the calculator, put our new function in. This is sine of x squared minus cosine of x. And we'll plug in all these values. If I plug in 0, I get -1. If I plug in 2 pi over 3, I get 1.25. If I plug in pi, I get 1. And now I want 4 pi over 3. I get 1.25. And now I need 3 pi over 2. And I get 1. So we have some absolute maximums of 1.25 is the highest, so that's at 2 pi over 3 and 1.25, and 4 pi over 3 and 1.25. And then we have an absolute minimum of -1. So 0, -1. Right. Let's do another one. All right, so this one. So far, all of the ones we have done, there haven't been any issues with continuity. So I haven't had to look, but this one throws a flag at me because it's a log function. We can't take the log of a negative number, right? So this, we have an issue because x squared minus 9, I need that to be greater than 0, right? So, okay, x squared is greater than 9. Then I have to take the square root, and I get plus and minus 3. And we have an issue there because we're undefined between those values. Undefined between -3 and 3. So we're not guaranteed any values. Right, because our domain that we were looking for was between -2 and 5. But we have an issue with what we can use. Right? Ooh, let's see this one. Oh my gosh, I wonder if my video is picking up. Can you hear the rain in the background? It is like downpouring outside right now. Okay. I'll probably rewrite this as x minus 2 to the 2/3 to do chain rule. So 2/3 x minus 2 to the -1/3 times derivative of the inside, which is just 1. If I set that equal to 0, we have 2/3, and I'm going to drop this to the denominator here. Now I don't have anything where it's equal to 0, right? Because if I multiply both sides by the 3 and then x minus 2 to the 1/3, if I multiply both sides by that, that just goes away and I'm left with 0 equals 2. So this function here will never be equal to 0. But I do have somewhere where it's undefined, which is just that denominator. So 3 x minus 2 to the 1/3, set that equal to 0. I can divide both sides by 3. still get 0. And then I can cube both sides to get rid of the cubed root. And I can add 2. So I do have a critical number of 2. So let's fill it out. So we're going x and h of x. We're going from 1 to 2 to 10. And I can plug this in. I feel like this one might be maybe easy. I don't know. 1 minus 2 is -1. Squared is 1. Cubed root of 1 is 1. 2. 2 minus 2 is 0. Cubed root of 0 squared is just going to be 0. And then 10. 10 minus 2 is 8. 8 squared is 64. Cubed root of 64 is 4. All right, so we do have an absolute max, an absolute min. Highest one is at 4, and the lowest one is at 0. All right, and that is all for Extrema. So if you have any questions, let me know.